and the continuation of the previous video. In that I have explained regarding some of the specifications to be considered while solving the design problems. And for the first examples is just see here, determine the maximum factor load to be that can be applied at a joint for some of the following cases. You need to find the maximum factor load that can be transferred in this joint. So this is the first case. This is a lap joint where the joint is the weld is given here. This is a 6 mm weld, that is the shop weld. I'll explain this, what is this. And and 16 mm thickness of the plate is 16 mm. Okay, just assume that Fe 410 grade steel. Assume that. If it is not given, you can assume the grade as Fe 410. So the ultimate strength of a plate will be, Fu will be equal to, that is 410 Newton per mm square, and the size of the weld given S is 6 mm, and the partial safety factor gamma mw is 1.25. This one, the partial safety factor is from page number page number 30. Table, the partial safety factor, table number 5, page number 30. For welds, for shop fabrication, that is 1.25, and the field fabrication it will be 1.5. You need to consider. Here it is given as the shop welded, so you can take it as 1.25. Therefore, and the length of weld. So the length of weld, they have mentioned only the weld. So here in this case, the weld only, it will be only here, not at this position. It is not mentioned, so no need of considering here. Only the weld is here. And the width of the plate is 200 mm. So this is 200 mm, and this is again at this down part it will be 200 mm. Upper part it is 200 mm. So the total length of weld will be 2 into 200. It is 400 mm. Next one, strength of weld or the joint, that is LW into T into FWD, or else LW into T into FU by root 3 into gamma MW. So effective throat thickness, that is T. LW you have got there. TE will be equal to K into S, right? Since it is almost, the faces will be in 90 degree, the face is 90 degree, almost 90 degree, you need to take it as 0.7 of 6, that is from table number 22, page number 78, you'll be getting there. 0.7 into 6 you'll be getting as 4.2. Next, the strength P will be equal to LW, that is 400, and TE, that is 4.2, what you got here, and FU is 410, and the root 3 into 1.25 gamma MW, that is partial safety factor. So the total answer will be 318.14 kilonewton. So the safe load, this is will be the factored load. So safe load will be calculating is the obtained value, factored load divided by 1.5, that is 212.09 kilonewton will be the safe load carried by this weld. Okay, that is again the strength of weld will the same strength of weld will be the load that can be carried by that member, that connection. The strength of that joint will be equal to the load that can be carried. So in this second case, we'll be considering here one plate, that is ISF, size is ISF 150 into 10 mm, will be connecting to a 12 mm gusset plate. Here you need to find the strength of load that can be transferred by this weld. Okay, and here in the previous problem they have mentioned only the two sides of weld, that is only in that problem only two sides welded it was there. Fine, only, okay, fine, it was like this, right? Here and here the weld, only the end welds were there. Here the three sides weld is provided. Okay, so anyhow let's continue, and again given is 5 mm field weld is mentioned. Okay, that is you need to consider while getting the value of gamma MW value. In that time you need to consider this is field weld. Okay, just assume the grade as Fe410. So the Fu becomes 410 Newton per mm square. The size of weld, anyhow it is mentioned as 5 mm, and the effective throat thickness, again this connection will be seen like this. Okay, fine, it will be like this. So this angle anyhow you can't see the angle here, but you can consider it as almost to 60 to 90 degree. You can consider, so you can take it as 0.7 of 5 from table number 22, page number 78, IS 800 2007. And gamma mw becomes 1.5 because it is mentioned as a field weld. From table number 5 you will be getting this one, page number 30. For field weld it is 1.5. For shop weld it will be 1.25. Okay, from table number 5. So the length of weld becomes now LW, it becomes 200 plus 200, 2 side welds plus 1 end weld. End weld is, the size of this plate is 150 into 10 mm. 150 will be the width and 10 mm will be the thickness. So 200 plus 150, 3 sides, it becomes 550. Now calculate the strength of weld. So strength of weld is LW into TE into FU divided by root 3 into gamma MW. LW is 550, TE is 3.5, what you have calculated here. It is 410, what you have assumed. Root 3 divided into 1.5, it becomes 303.78 kilonewton. So the safe load will be equal to it becomes this is the factored load, so divided by 1.5 you can get the safe load or the service load that can be transferred by that connection. The load that is transferred means it is same as that of the strength of weld. Up to that strength, up to the strength of weld, up to this limit, the load can be transferred. Once the strength is failed, you can't carry any more load. So the strength of weld is also equal to the load which can be transferred by the connection, transferred by that joint. This in this problem, take another problem. In this problem, they have mentioned this a tie members 75 into 8 mm. The plate 75 into 8 mm plate will, and this is the width and this is the thickness, is to be transmit a factored load of 180 kilonewton. So the load is already given. How much load it has to take they have given. Okay, you need to design the fillet weld necessary to lap the joint. You need to design that is the length of weld you need to design. You need to calculate what will be the length of, or what will be the overlap you need to provide here. That you need to calculate here. Okay, you need to consider the grade of steel as Fe410 and the thickness of gusset plate will be 12 mm, where the tie member is to be connected by using the weld. Okay, now here the solve by considering the 3 cases. One case, that is only side weld with end returns are used. Only side weld in the sense you need to take only this side and this side weld you have to consider. No need of considering the weld here. Okay, no need of considering the weld here. So you have to consider only this much. And end return, what I have explained that regarding while explaining the specifications, end returns, that is 2 times the S will be the size of the weld. Okay, now let's solve this question. So grade of steel is 410, what I have assumed. So Fu becomes 410 Newton per mm square. Now assume it as shop weld. They have not given anything regarding shop weld or the field weld. So you can assume anything. Just assume it as shop weld. So gamma MW becomes 1.25 from table number 5. Page number 30 you will be getting this. That is IS 800 2007. Load has to be transferred here is again that is 180 kilonewton, and maximum plate thickness is 12 mm, that is gusset plate, and the minimum thinner plate is 75 to 8 mm. 8 mm is the thickness of the thinner plate and 12 mm is the thickness of the thicker plate. Okay, so you need to, here the size of weld is not given, only the load is given. The size of weld, yes, the smallest, that you need to find the size of weld. So just first to find the minimum weld size, that one from table number 21, page number 78 you will be getting this. From the table, depending upon the thinner plate, the minimum size of weld you need to consider here. That is 0 to 10 mm plate, it will be 3 mm, 10 to 20 it is 5 mm. Here the thicker plate is gusset plate, that is 12 mm, they have given as 12 mm. So 5 mm is the weld size you need to consider here. The minimum criteria will be 5 mm. And the maximum weld size, I have already mentioned that here if this is a 2 plate, if this is a weld, here the 1.5 mm gap you need to provide here. So the maximum will be equal to T minus 1.5 mm. This is a gap and this is the thinner plate. This is a thinner plate. So here the maximum weld size becomes, thinner plate is 8 mm. This is 75 into 8 mm. 8 mm is a thinner plate, and minus 1.5. This is minus 1.5 you need to consider here. So it becomes 8 minus 1.5 is 6.5 mm. So now you have the minimum limit and the maximum limit, 5 mm and 6.5 mm. You need to take between 5 mm and 6.5 mm. I'll be considering here use 5 mm weld, that is S is 5 mm. Limit will be 5 to 6.5. So the effective throat thickness becomes now TE will be equal to 0.7 of T. Anyhow, this face will be in 60 to 90 degree. You need to consider that much only, because you don't know exactly what is the you can't see here what will be the angle. You can take it as 60 to 90 degree criteria. From table number 22, the K value, it becomes K into S, right? K into S, throat thickness K into S. This K value, this is a constant you will be getting from table number 22. For 60 to 90 degree, it will be factor will be 0.7. 0.7 into S is 0.7 into 5, that is 3.5. That is 3.5 mm. Okay, now throat thickness you have got. Now find the strength of, from use the formula, that is strength of weld, that is LW into TE into FWD, that is LW FU by root 3 into gamma MW. So here actually what I already told there, the strength of weld will be equal to load that can be transferred, right? Till up to the strength of, up to some strength of this weld, the load can be transferred. Or once the strength of the weld is exceeded, if the weld is failed, it can't transfer the load. So the strength of weld will be the maximum limit for the load transfer. Fine. So you can take it as the strength of weld equal to load to be transferred. It is given as 180 kilonewton, which has to be transferred into LW into 3.5 into 410 is FU. This is TE already given. Root 3 into 1.225. This is shop weld that you have considered. So LW becomes 271.57 mm. By calculating LW, you will be getting as 271. So it is, so you can consider it as 272 mm. Therefore, length of weld in each side. Here it is already given as length of weld. Here the case is only you have to take only the side weld you have to consider, right? So length of weld in each side becomes 272 by 2, that is 272 by 2, it is 136 mm. This is the total length of weld, that is 272 mm. So each side becomes 272 by 2, that is 136 mm. Again another condition is there, end return, you need to provide the end returns, that is limit is 2s. End returns you have to, minimum end returns what you need to provide is 2s, that is 2 into 5, that is 10 mm. So each side becomes 136 plus 10 and 136 plus 10, that is 146. 136 and plus 10 mm. This is end returns and this is the effective weld you need to provide. Okay, therefore provide the side weld of length 146, 136 plus 10, 146 at each side. Fine. That is one case. Okay, now let us go for the second case here. Side weld of one side, you need to provide the side weld and one end welds you need to provide here. Okay, in the second case, in the previous case you have taken only the side weld. Here 3 sides you need to provide, 2 side welds and 1 end welds you need to provide here. Fine. Up to this calculation, up to this 272 calculation, it is same. Okay, now just a distribution you need to change here. Distribution is total calculation, LW is 272. So width of the plate is given as 75 mm. This is given as 75 mm. So if it is 75 mm, the side weld becomes how much? Anyhow, you need to provide the side weld. I think no, it is not here. You need to provide the side weld as. So if I consider, see, if this is a drawing, if this is the case, okay, this is 75 mm, 75 mm. Let here you need to provide the weld, here you need to provide the weld, and here you need to provide the weld, right? Anyhow, this width will be 75 mm. You already got, right? Total is 272. So what will be the side weld? 272 minus 75 by 2, right? So 272 minus 75 divided by 2, that is 98.5. You can take it as 100 mm both sides. So total here 100 mm, here it is 100 mm. So 100 plus 100 plus 75, it becomes 275 mm. Required is 272 mm is required. So you have considered 272 is required. You have considered 275 mm. So it is fine. Okay. And next case, third case, here it is they have given us for side weld. You need to provide side weld and both end welds you need to provide. That is side weld, anyhow you know this is a side weld, and both end welds you need to provide. Okay, fine. So the length of length required was 272 mm, right? 272 mm. The calculation will be same up to LW. LW was 272. Okay, and anyhow you know this part is 75 and this width is 75. So here it is 75. That is, if you do a what here, if you do cross a side view, so this will be seen here, this here as a triangle, and this one below the plate, it will be like this, you can see here, and the side weld will be seen here. This will be the side weld. So four sides, and this one and this one, that is here and here, it is 75 mm. It is already fixed. So 75 plus 75, it is 150 mm. So remaining is almost 130 remaining. So if you distribute here, you can take it as 75, 75, 75 and 75. That is total is 300 mm. So all the four sides, if you provide the 75 mm, so 300 mm required was 272 mm was the required, and you have provided as 300 mm. Yeah, provided. Hence it is fine. The length of weld is fine here. Okay. So let us go with the one another problem. Let us go with another problem. That is here they have given, in this problem they have just they have not given any load to be transferred, or they have not even mentioned regarding the size of weld or the length of weld. They have not mentioned anything regarding that. Fine. They have just given a 200 mm wide 16 mm thick plate is to be connected to the gusset plate. They have just told us 200 mm width of the plate is 200 mm, and the thickness of the plate they have given. Okay, that is 16 mm used to connect by using, okay, size of the weld they have given, that is, yes, 8 mm shop weld they have mentioned. Okay, you need to determine the length. This length you need to determine. That is the lap length, how much it has to lap, how much it has to sit over how much length it has to sit over another plate, over this gusset plate, how much length it has to sit, or overlap, how much length it has to overlap. You need to this overlap you need to calculate here. Okay, fine. Now here 8 mm shop welder they have given. Determine the lap length required to develop the full strength of the flange. Okay, how much lap you have to get the total maximum full strength, how much lap you need to provide. Weld you need to provide only these three sides, you need to provide the weld. Okay, so let us solve this. Now just assume the grade of steel as Fe410. They have not given regarding any grade of steel, so you can assume it as Fe410. You need to assume here. Okay, now here see, they have not mentioned anything regarding which I have already told regarding. They have not mentioned anything regarding the total load to be carried, right, or the length they have not given, right. So here what you have to take, the strength of the plate, fine, that is total TDG you need to take. Okay, the strength of the plate you need to consider, you need to calculate the gross section. No need of calculating the net area because it is not a bolted connection. No area is lost here, right? No area is lost due to any holes. Here in this what the another advantage of the welded connection, that is no area is lost. Complete area is taken to carry the load, no concentration of load, right? So no need of carrying any net. you need to take the total gross design strength of the plate due to the gross section yielding. That strength you'll be taking as the strength of weld. You have to consider as the strength of weld. Strength of plate due to gross section yielding you need to calculate, and that load you need to consider as the strength of weld, because you don't know the total, don't know any other parameters to calculate the strength of weld. The strength of plate you have to consider here. Okay, so while calculating the strength of plate, TDG equal to AG into Fy by gamma m naught. From page number 32, clause number 6.2, you can get this formula, that is TDG is AG into Fy into gamma m naught. You can see here TDG equal to AG into Fy by gamma m naught, TDG. Okay, so here this one, just a minute. Okay, so now calculating AG. AG is the gross area, that is if you take this as a plate and this is connected for this one, so gross area will be equal to, if you take a cross section you can see like this, if you take a cross section here and see from this side, you can see the plate like this, right, the top plate. This will be the gross area, that is width into thickness, that is gross area. Width is 200 mm, this is 200 mm, width is 200 mm, this is okay, and the thickness is 16 mm, that is already mentioned in the problem. 16 mm, 200 mm into 16 mm thick plate. So the gross area is AG is 200 into 16 into 250 divided by 1.1. This is gamma m naught. Again this one you will be getting from table number 30, that is gamma m here, governed by the yielding partial safety factor will be 1.1 here. So by substituting all the values, Fy it becomes, Fy we will be getting from it is mentioned here. I'll show from table number 1 itself, from page number 14. Here see, you can see for less than 20 you can take it as value as yield value as 250 for 410, ultimate strength 410, you can take it as 250, you can consider there. Okay, so this is 250, 216, 250 divided by 1.1, this much 72.72 Newton, that is 727.27, or by rounding up 728 kilonewton will be the strength of the plate. Now Fu I have assumed as 410 Newton per mm square, and it has again another thing mentioned here, it is a shop weld. Fine, it is mentioned as a shop weld. So if it is a shop weld, the gamma mw becomes 1.25, right? So throat thickness is TE becomes 0.7 of, yes, you know, this angle you will be considering as 90 degree, the angle between the plates, used, you will consider this angle as 90 degrees, so or 90 or 60 to 90, something nearly equal to that. So this is K into S, so K value is 0.7. From page number 78, table number 22, this value you will be getting, right? So it is 0.7 into 8, yes is 8 mm, it is mentioned in the question itself, right? 8 mm shop weld, using 8 mm shop weld, so yes is 8 mm, so 0.7 into 8 is 5.6. Now the strength of weld formula, P equal to LW into T into Fu by root 3 into gamma mw. So strength of weld will be equal to strength of plate, just equating the strength of, you don't know any other parameters. Okay, so strength of weld equating to the strength of plate, that is 728 is the strength of plate equal to the strength of weld, that is LW into T into Fu by root 3 into 1.25. So L becomes 686.48, that is 670 mm, almost rounding up to, sorry, 686, right? So you can round it to 690, you can round it up to 690, round it to 690. Fine. So 690 minus 200 divided by 2 becomes 245. Okay, fine, 690, right? So the provide the end welds, end weld, it has is 200 mm, right? Width of the plate is 200 mm. So this side is 200 mm, end weld is 200 mm. Remaining is 690 minus 200. That is remaining you need to provide for the side weld, that is overlap, right? So 690 minus 200 divided by 2, that is 6, total 690 minus 200 divided by 2 becomes, that is 245. Each side you can provide up to 245 mm, you can provide 245 mm you can provide for each side. So total becomes here 245 and 245 plus 200, that is 690 mm you will be getting here. So the total overlap or the lapping, total overlap or the lapping is 245 mm, which you were asked to calculate the value.